All right, welcome to LouTube and this video lesson on solving quadratic equations by completing the square. This is by far one of the more challenging concepts of grade 10 math, but it is doable, and I'm going to try to break it down in this video as to how to do this. The previous lesson we did solving quadratics by factoring, and in these examples, you're going to see this method is used for when we cannot factor a quadratic equation, and that does occur. So there are situations where we cannot factor, and then we must use completing the square. Now, I am going to do a basic simple one that is factorable and show you how completing the square works with a factorable one so that you can see the comparison. One of the things you need to understand is that when we're doing this, we're going to need to understand this concept here, which is the b term divided by 2 squared must equal the c term to make what's known as a perfect square. So if you're looking at this particular activity or going through this sheet, this is the key thing here, and I'm going to explain that as we work through our questions here. Okay, so I am going to work through a couple of examples. I find that is the best way to solve these particular questions. Okay, so what we're going to do is I'll do the first example by factoring, and then I'll do it over here by completing the square. So on the left by factoring, and over here on the right by completing the square. Okay, and you can see for yourself which method is easier. Clearly, I think that factoring is going to be easier. But so this one here, I have factors of 16 that have a difference of 6, which will be 8 and 2. So if I know how to factor, I'm going to x plus 8, x minus 2 equals 0, and that is factored. And then quickly I can see my answers are x equals minus 8 for this one and plus 2 here, and I am essentially done. I have completed solving this by factoring. Now, when we're going to do it by completing the square, we're going to see that the result is somewhat different. So what we're going to do, first of all, is we're going to just isolate the x squared and the x and have the constant over to the other side. That's the first step. So now instead of it having equal to 0, we're going to have it equal to whatever the number is. So that 16 is going to come over to the other side. So we're going to add 16 to both sides. We're going to get x squared plus 6x, and I'm going to leave a space here for the c term. And what I want to do is I want to complete this to make it a perfect square. And this is where I go back to my original concept of understanding perfect squares for trinomials, and I understand that this number 6 divided by 2 and then squared will equal my c term right in here. And so 6 divided by 2 is 3. 3 squared is 9. So I'm going to add 9 right here to this question. Now, I can't add 9 to this side and not add 9 to this side. That's the rule of, dealing with equations. Whatever you do to one side of the equation, you must do to the other. So I add 9 over here. And then I move to the next step and I say, let's factor this. And I say, well, I made this into a perfect square. So you'll see that factors of 9 that add to 6 are 3 times 3. And I did that on purpose so that I'd get x plus 3 times x plus 3. And so the answer here is x plus 3 squared. And over here, it's 16 plus 9 equals 25. Okay? Now, the next step would be to take the square root of both sides. Now that I've isolated this as a perfect square right here, I can square root both sides. So I square root this, and I square root this. And what I end up with is 5 plus or minus on this side, and just x plus 3. And this essentially means I have two possible answers. Some number at plus 3 will equal 5, and some number plus 3 will equal minus 5. So essentially, I write it like this. X plus 3 equals 5, or x plus 3 equals minus 5. And now I solve each of these. In this case, I'll subtract 3 from both sides, and x will equal 2. And then I write or, and then over here, subtract 3, and x equals minus 8. And you will see that I ended up with the exact same answers as over here at factoring. I don't think there's any argument that this is a much easier solution than this. There is no way, if I can factor a quadratic equation, that I would not be choosing to use factoring. But if I cannot factor it, then my only option is to come over and use this method here, which is completing the square. So let's look at some examples where we cannot factor it, and we can check that we cannot factor them first, okay? So let's go through a few of these examples, and we'll go from here. So if I look at my very first one, minus 8 plus 4, so I ask myself, factors of 8 that have a difference of 4. Well, the factors of 8 are 8 and 1, they have a difference of 7, and 4 and 2, they have a difference of 2. So this is not factorable because there are no factors of 8 that have a difference of 4. So I have no choice. I must use completing the square. So once I've realized that, I get to it. I write x squared here plus 4x. I leave a space for my c value, which I'm going to calculate here, and I say it equals 8 because I've moved the 8 over to this side. It'll be positive because really I'm adding 8 to both sides. Now, I have to figure out what my c value is here. Well, I do that by taking my b value, which is 4, and dividing it by 2, and then squaring it. Well, what's 4 divided by 2? Well, it's 2. What's 2 times 2? Oh, it's 4. So I add 4 in here. That equaled 4, right? That math is essential. In this case, it happens to equal the b value, but that's just by coincidence, right? I added 4 here, so I must remember to add 4 over here, okay? Now, this here is giving me a perfect square. Factors of 4 that add to 4, 2 and 2. So I write x plus 2 squared, okay? It is a perfect square. And that's the whole purpose of doing this, is to get a perfect square right here. This equals 12. And now I'm in a situation where I can take the square root of both sides. Taking the square root of both sides, I end up with x plus 2 equals plus or minus the root of 12. And in this particular case, there is nothing I can do with the square root of 12 because it's not a perfect square. So I just leave it as the root of 12, okay? And I get my answer by taking my plus 2 and bringing it over to the other side, which makes it into a minus 2. And typically, we don't write it as minus 2 on the back end. We typically write that in front of this. So we write the answer as x equals minus 2 plus or minus root of 12. So that means we would take 2, add the square root of 12, or we take 2 and subtract the root of 12, okay? Now, it's a little confusing for some students because they'll look in the back of the book and it won't say this answer. The correct answer will not be listed as this. They will actually show the answer as minus 2 plus or minus 2 root 3. And this is confusing to students because where the heck does this 2 root 3 come from? Well, it's essentially what they do is in math, they take root 12 and they break it into root 4 times root 3, where root 4 is a perfect square. So anytime a perfect square can multiply into the square root, they'll do that. And then they'll take the square root of 2, which will make it square root of 4, which is 2, which will make it 2 root 3. I'm okay if you leave the answer in this form. we haven't spent a lot of time doing it in this format, so I will accept that. But your back of your textbook will probably give this answer, whereas I will accept this answer, okay? All right, let's try another one that's a little bit trickier over here where the numbers are getting a little bit bigger, okay? And we're going to see some issues with respect to this, okay? So in this particular case, what happens is I've got this answer here, and I'm going to say factors of 39 that add to 14, or sorry, 38 and add to 14. Well, the only factors of 38, I believe, are 2 and 19, and they add to a total of 21, not 14. And the other two factors would be 1 and 38, and they would add to 39. So there's no way we can factor this. So what we would do is we would move the 38 to the other side, which makes it minus 38, and then we'd have x squared minus 14x, and we'd leave a space over here because that's the step that we're going to follow when we're completing the square. Now, for getting the value of c, I'm going to take my 14, right, and divide it by 2 and square it. Well, that equals 49. That's 14 divided by 2 is 7. Squared is 49. So I'm going to add 49 right here. That means I must also add 49 to this side of the equation. Okay? And at this point, I can now go about doing my math and adding on this side and factoring this into its perfect square. And this time we have a minus in the middle, so this is going to be x minus 7 squared. And if you don't believe me, factors of 49 that add to 14 are 7 times 7, okay? And that's where I get x minus 7 squared, okay? Because it's going to be x minus 7 times x minus 7. Then over here, I have 49 minus 38, essentially. That is going to equal 11, okay? Now, I'm going to take the square root of both sides. So I take the square root here. I take the square root here. Remember, whenever we take the square root of a number, we must include plus or minus on it. So I end up with x minus 7 equals plus or minus the square root of 11. And then the minus 7 comes over, and it always goes in front of the square root, and we end up with 7 plus or minus the root of 11. And there's no number here, there's no perfect square that will multiply into 11, so that will there be your final answer. And you're done. And by the way, that does represent two answers because it represents x equals 7 plus the root of 11 and x equals 7 minus the root of 11. So those are your two answers that you're essentially stating in one statement there. Okay, let's move down and do a couple more. A little bit more challenging ones. So all of these add different elements of things that get different and that I can help explain. So stay with me as we work through all of the examples, okay? So in this case, this particular one, we're now going to have x squared. I'm going to move the minus 8 to the other side. Oh, by the way, factors of 8 that add to 4. Once again, there are no factors of 8 that add to 4. 4 and 2 add to 6, and 8 and 1 add to 9. So that does not help me. It's not factorable. So this comes over, becomes minus 8. I write x squared plus 4x. And then I want to find my c value. To find my c value, I take my b value, in this case it's 4, divide it by 2, and square it. And that will turn into my c value, which I'm going to write right here. So that will actually equal 4. So I'm going to add 4 here. Okay, and then I add 4 over here as well. And so now I end up factoring this to be x plus 2 squared equals minus 4. And now I want to take the square root of both sides. Well, I get the square root of minus 4. Well, I'll tell you something. Try it on your calculator. There is no answer here that will work. Okay? This is impossible. It cannot happen. You cannot take the square root of -4. Now, we can say there is no solution here. And essentially, there is no solution. That is correct. So, therefore, no solution at this point. Now, what sometimes happens is they do this here. Sorry, I got to erase there. Let me get my eraser. They sometimes will write this as I root 4. In other words, it's an imaginary number, plus or minus the imaginary number of root 4, which is actually going to be 2, right? It's going to be I2. And that will equal x plus 2. And so in the end, we get x equals -2 plus or minus I2, which is an imaginary number. It doesn't really exist. We don't tend to do this. We tend to stop right here. But I like to explain to students that it can be sometimes referred to as an imaginary number. It's a weird thing, but believe it or not, there are imaginary numbers, just like your imaginary friends from when you were a child. Okay. And I would say we're going to just end it here at no solution when we get a square root of a negative number. Okay. Let's move on to another one. In this case, we have a 4 out in front of our x, and this creates all kinds of challenges. So what we're going to do, same thing, we're going to move the 3 over to the other side. That's -3. And then we're going to have 4x squared plus 12x, and we're going to want to put in here. But we don't want to do this with the 4 out front. That's just way too tricky. So what we're going to do is divide everybody by 4 in the whole thing. So we divide this by 4, this by 4, this by 4. Everybody gets divided by 4. So this is -3 over 4 now. And over here, this is going to be x squared plus 3x. Oh boy. So this creates for a really interesting situation because I now want to find my C value. Well, what is my C value? My C value is actually going to be 3 divided by 2 squared. So 3 over 2 squared. Well, this is a fraction. This equals actually 9 over 4. And that's okay. We're just going to leave it as 9 over 4. We're going to write plus 9 over 4. Okay. And that means I have to write plus 9 over 4. And see how by leaving it as 9 over 4, I actually have a common denominator here. This worked out really nice for me, okay? And so don't get jumping and moving it to decimals and doing stuff like that. Just leave it in a fraction form, okay? This will factor to be the square of x plus, it's always the 3 over 2 squared equals, and now this is going to be 9 take away 3, which would be 6 over 4. That's just adding and subtracting a fraction there, and that is using those rules. We have a common denominator already, so we don't have to worry about it. We just take the -3 plus 9, which is actually 6. Now I'm in a situation where I can take the square root of both sides. So I take the square root of both sides, and this, of course, will be plus over plus minus, okay? And now I end up with x plus 3 over 2 equals the square root of 6 over 4. Now, this is something that'll be new for you, but you can do square root of 6 over the square root of 4. So that actually ends up being the square root of 6 over 2. Okay, and that's kind of handy here because we end up with plus or minus the square root of 6 over 2. And when the 2/3 comes over, it's going to be minus 2/3. So it's going to be minus 2/3. Oh, sorry, 2/3. 3 over 2. It's not 2/3. I'm saying it backwards. Sorry. Minus 3 over 2 plus or minus 6 over 2. Root of 6 over 2. Sorry. And this equals x. And now what they typically do is, because we have a common denominator, they bring the denominators together and write the top separate. So the textbook answer will typically be 3 plus or minus the root of 6 all over 2. And there is your answer. Rather complicated, really means minus 3 plus the root of 6 divided by 2, minus 3 minus the root of 6 divided by 2. Those are your two answers. But there is your final answer right there. And it's not really that easy, but that's how it works, okay? Let's do a couple more practice ones here, and then we'll call it a lesson. And really, it's just about practicing, asking for assistance if you're not getting it, and moving forward, okay? So again, here, what I have is minus 32 on this side. So 32 comes over. I'm going to have x squared minus 8x. And then I have to figure out what I'm going to add in here. And it's always add, by the way, because a perfect square is always going to be a positive there. So it's 8 divided by 2. That's going to be 4 squared. So I'm going to add 16, add 16. And right away, I see, oh, I'm thinking factors of 32 that add to 8. I don't see any, but I do see factors of 32 that have a difference of 8. Maybe, no. There was no factors. Would have been good if there was factors and I saved myself this challenge. But anyway, I end up at minus 16 here, and I end up with x squared, x minus 4 squared, right? And right away, I see I have a negative answer here. So this is no solution. And you don't have to go on and write imaginary number answers. I'm okay. Just leave it at no solution. There is no real solution. Actually, that should be really in there. You should write the word real, because there is a fake one. There's an imaginary one. There's no real solution here. Math is getting really abstract when we got real answers and fake ones, and who knows, next thing you know, math's going to be right in there on the fake news or something, right? All right, let's try this one here. A little more tricky, a little more complicated, but again, let's move the 8 over to the other side. 8 here, we're going to have 2x squared minus 5x. Now we need to find the answer here. Well, that's going to be 5 over 2 squared. That's going to be 25 over 4. 25 over 4. So we're going to add 25 over 4. And then typically what I would do is I would encourage you to actually convert the 8 into a fraction, which is 32 over 4. And that's going to be then added to the 25 over 4. So you might do that math off on its side, and that works out to 57 over 4. So hopefully you understand that that 8 there is 32 times divided by 4 is what 8 is. That's what 8 is, and plus 25. So this works out to 57 over 4. And then over on this side, I end up with x minus 5 over 2 squared, because I'm going to take it into its perfect square form. And remember, the b value, divided by 2 will always be what goes here, or the square root of this number. Oh, I screwed up. My bad. Got to go back. I hate it when the teacher screws up. I'm not going to redo this whole video for this. I messed up because there's a 2 in front of the x squared. I missed it. Look at that. Let's go back here. I'm at minus 8. I must first get rid of the 2. I forgot. So I have to divide everything by 2. So this would be plus 8, right? This would be 4, okay? And this becomes x squared minus 5 over 2x plus 4. Now I need to find my c term, which is going to be different. It's going to be 5 over, I'll do it over here, 5 over 2 times a half. That's going to be half of it. It's going to be 5 over 4 squared, which is going to be plus 25 over 16. Plus 25 over 16. Oh boy, that's totally different, right? So 4 over 16 plus 25 over 16. So we're going to actually add those two off to the side. So 4 times 16 is 64 over 16 plus 25 over 16. And what does that equal? Well, I believe that equals 89, all right? So that gives me 89 over 16, okay? Now, you can see how having your fraction skills down really good and then recognizing things correctly and don't make the same mistake I did and forget that 2 had to be divided through first, okay? Now, what happens is I can factor this and it'll be x minus 5 over 4 squared. Okay, the square root of this goes in here. It's minus because there was minus in the middle. Now I'm going to take the square root of both sides. It's going to be the square root of 89 over 16 plus or minus, and then this is going to be x minus 5 over 4. Oh, I don't need the brackets there. Sorry, I didn't need them because that's the whole point of taking the square root of both sides. Sorry, I should maybe write that in there, square root of both sides. So this is 89 over 16. Now I'm going to have this as the square root of 16 is 4, so I'm going to write, and then the 5 is going to come over, so it's going to be 5 plus or minus the square root of 89 all over 4 when this 5/4 comes over, and that is what x is going to equal. Wow, that's a pretty tough question, I have to admit. You're going to have to do some practice with your math skills. All kinds of little mistakes can happen along the way with this. It's my least favorite topic to teach grade 10 math kids because, yeah, you know, it is tough. It's really tough. But the really bright kids who work at it, practice, and go through it, they will eventually get this. But I suggest you do multiple examples and lots of practice to get this down. Some students just simply, they really struggle with it. It is very complex, especially the more detailed ones where the value of a is greater than 1. It gets pretty tricky. All right, so that's the end of this lesson on completing the square. The good news is the next lesson is a little bit easier when we start using the quadratic formula. All right, hope you liked it. See you next time on Lucy.